Okay, so as Milesh mentioned, today I'm going to talk about the economic perspective on discrimination, and hopefully this should really connect nicely with Juva's talk on algorithmic fairness and some of the issues related to discrimination and fairness in computer science, because I think there's a lot of really interesting work at the intersection of these two fields going on right now. So I'm going to start with a super simple background example of what the economics of discrimination has looked like in terms of modeling and identification over the past 50 or 60 years. And then I'm going to come right to the forefront and start talking about some of the new issues that we've been thinking about in the past 5 or 10 years within economics. So I'm going to do all of this in a very simple framework, a simple hiring task. And we can suppose a manager is evaluating a worker. The worker is characterized by some unobservable productivity, which we denote by Y, and some observable group identity, here, M or F, we could think of male or female. Of course, could also be racial identity, ethnicity, religion, anything else along the lines of which we may be interested in seeing whether discrimination is occurring. And now this worker, although productivity is unobservable, they generate some observable signal of this productivity, be it a recommendation letter, a test score, the outcome of a health test, say prior criminal record, a lot of different things that this signal could be. And for starters, we're going to say the manager uses some decision rule to determine the action to take given their information set, that is the group identity and the signal of productivity. So we let A of GS denote this action rule. And in a couple of slides, I'm going to provide a foundation for this in terms of preferences and beliefs. Here, we're going to just be talking about a hiring task, but there's many other relevant domains we could think about for all of the discrimination research within economics. It's often looked at empirically in terms of education, lending, healthcare markets, criminal justice, many other settings. So if we look at the classic definition of discrimination within economics, economics is really mostly focused on a causal definition. And what I mean by this is that all else equal, if you flip the group identity, disparate treatment is what would be what we call discrimination. More formally, and we're going to call this direct discrimination, as some of the research I'm going to talk about today is trying to expand this notion. So this notion of direct discrimination says that the manager's actions exhibit discrimination if the action rule for a male who generates signal S is not equal to the action rule for a group F or a female who generates signal S for some signal in the signal distribution. In other words, a group M and a group F worker receive systematically different evaluations when they generate the same observables aside from their group identity. So this has been well documented causally in the economics literature. We've seen discrimination along racial lines, ethnic lines, gender and sexual orientation. It's been documented in a variety of different domains: hiring, lending, criminal justice, healthcare, so on and so forth. The key method that's used to identify discrimination is often what we call an audit or a correspondence study. And so the issue with identification is that often you can't just compare the outcomes, say, for two different groups of workers or two different groups of, say, loan applicants, because they may have systematically different performance. And so in order to get at this causality, you essentially need something akin to random assignment of group identity. And so that's what an audit or a correspondence study does. An audit study essentially has confederates be trained to generate the exact same signal and to go present themselves along the group identity. Whereas a correspondence study is often something where you say generate, the classic one is the Bertrand-Mullinathon 2004 paper, where they generated resumes that were identical aside from the names, which were made to either have African-American or white sounding names. And then they looked at the differential callback rates for these resumes that were essentially randomly assigned to perceived race, and that differential callback rate was their measure of discrimination. So these are the key identification methods when we're looking at discrimination as a causal concept. Now, the other question economists have been interested in historically is, what are the drivers of such discrimination? So why do we, when we see this differential treatment conditional on the same signals, why are we seeing this? What's the underlying model that's generating this differential treatment? And so in order to get at this, we need a bit more of a micro foundation for this action rule, specifying how the manager behaves as a function of whatever they observe about the work. So let's put this in a classic economic decision environment. Let's suppose the manager chooses some action A. The manager has a payoff or utility function that depends on their action choice, the underlying or unobserved productivity of the worker, as well as potentially the worker's group identity. Now, because this productivity is unobservable, the manager is using this signal to draw inference about it. So the other relevant piece of the puzzle here is the beliefs about the productivity and signal distribution. We call the underlying prior distribution of productivity the productivity distribution. That's the potentially group identity specific distribution of productivity. It may vary by group, it may not. And then when we call this signaling technology, the distribution of the signal conditional on a given level of productivity. And of course, that could also potentially vary by group identity. So these are the two relevant distributions for the decision. The manager uses Bayes' rule to form a posterior belief about the productivity of a worker, given the observed signal as well as the observed group identity. And then they choose their action rule corresponds to maximizing expected utility with respect to that posterior belief. So just very classic decision problem where discrimination can come into play is based on how the manager's payoffs and beliefs may depend on the group identity. All right, so historically, the literature is focused on two potential sources. One is the first model of discrimination by Becker back in 1957. He came up with an idea that it could be tastes or preferences. In other words, managers could have animus against members of a certain group, and that would be what's generating the differential treatment. So here that would correspond to managers' payoff depending directly on the group identity. Alternatively, as we started to move towards thinking about information more in economics in the 70s, informational theories of discrimination came about. And the idea is that maybe the manager doesn't inherently care about the group identity or have any animus towards a group, but the group identity could be informative about productivity. So it's another piece of information in addition to the signal. In other words, formally, the posterior belief of productivity conditional on the signal also depends on group identity. So Phelps and Arrow first model this as differences in, say, the average productivity. If one group has a lower average productivity than the other, then even if you see the same signal, you would still have a lower posterior belief about the expected productivity and therefore treat the workers from the group with the lower average productivity with lower evaluations. Egner and Kane also started thinking about variance of productivity as well as the signal precision. There's a really nice new paper by Benson, Mortimer, Terven looking at this idea of signal precision. Essentially, they show that they look at Black, Hispanic, and white managers and show that they're often more effective at screening workers from a similar racial or ethnic background. And so if you therefore have imbalance in terms of the managerial composition, you can see discrimination because workers are not being screened by the people who are most effective at screening them. And so naturally, once we have a theory of where discrimination may come from, the other question economists are interested in is how can we identify these sources? So how can we distinguish between, say, discrimination from a taste or preference-based source and discrimination from a statistical source? And the key method here, there's been many different methods, but sort of the key one that's used in many papers is what is called an outcomes-based test. And that's where if you can observe the true distribution of productivity, then you can use that to back out, do these decisions make sense with respect to that distribution? If yes, it must be statistical. If not, if they can't be, if they're not consistent with that distribution, then it must be taste. There must be tastes that are generating this differential treatment. Oops. Okay, so what I want to talk about today now is expanding the framework for how we think about discrimination in economics. The first thing I want to do is I want to pose a third potential source that's inaccurate beliefs. As I said, we started out with Becker's classic model of taste-based discrimination. As we started to think about information and economics decision-making in the 70s, that's when the statistical discrimination came in. Well, now in the 90s and 2000s, we've had a rich literature in behavioral economics start to think about how beliefs are inaccurate or biased or systematically wrong. And I think that very nicely brings us to applying that to the discrimination literature. A third source that we could have is these inaccurate beliefs. Then I also want to talk about how we can also expand the notion of the environment in which we're looking for discrimination. Often it's been looked for in a static decision, so just a one-off decision, is there discrimination here or not? We also have a really nice theory of dynamics and how things evolve dynamically on the microeconomic theory side of things. And it turns out that has a lot of applications to how we can think about discrimination being linked across time. How is discrimination in one point in the pipeline going to influence discrimination we see at subsequent decision making? And so I think I'm going to argue that it's important to look at this whole picture. Sometimes looking at things as an isolated decision are not going to give you the full picture of what's really going on in the market. And then lastly, and this is going to really probably be the closest part related to computer science and really connect to a lot of the things Yuba said in the first tutorial, is the idea of expanding the definition of discrimination. And so as I said, discrimination in economics has been synonymous with causal effect of group identity on actions. We're going to call that direct discrimination. And I want to argue that we should expand the framework to also look at indirect sources. In other words, how can we account for discrimination emerging from interactions across different domains, different time periods, different systems that are going to influence the treatment in the current decision? Okay, so to start out, we look at the third potential source, inaccurate beliefs. This is based on work I have with Alex Emas, Kareem Hagag, and Devin Pope. And there's also been a lot of really nice empirical papers coming out recently trying to identify inaccurate beliefs in different settings. And so we argue that people have systematic biases in their beliefs coming from the behavioral literature. It may be because of, say, inaccurate stereotypes. Bordalo et al. Has a really nice model of how inaccurate stereotypes can lead to inaccurate inference. There's a huge literature in psychology discussing how stereotypes can be inaccurate. Inaccurate beliefs can also arise from simply a lack of information. It could be people are making decisions from an inexperienced place. They may be using subjective information. So for example, a recommendation letter is something that I call subjective information. It's information generated by another economic agent or by a manager, as opposed to exogenous information, which is, say, a test score, where if you see the score of a say SAT test, it's multiple choice, you know that that was scored correctly. And even if the test itself is biased, the score is the correct thing. Whereas something like a recommendation letter, it's filtered through other people's preferences and beliefs. And so in order to interpret that recommendation letter, you need to have some sort of model of other people's preferences and beliefs. Now that's a lot more complicated than having a model of, say, how test scores are generated, because there's a lot of heterogeneity in beliefs and preferences. It's not something you can really easily observe. And so, it's quite complex to have a full understanding of how recommendations are generated based on how other people choose to write them. Lastly, it could be that people have pretty accurate priors about population averages, but inherently we're in a dynamic world and people are unsure about how selection impacts the current population. So maybe you have a relatively accurate model of, say, productivity for people who arrive at an entry-level position from university, but if there's discrimination or selection in the pipeline, then once you reach the promotion stage, you have a less accurate model of how that, say, distribution conditional on reaching a given stage has evolved across time. So all this to say is that it's really difficult to be fully correctly specified or have accurate beliefs at every decision point, and also about everyone else who is generating information that you observe. And therefore, inaccurate beliefs seem like they'd almost be sort of, a very likely thing to emerge, at least in some settings where people are doing evaluations. How do inaccurate beliefs affect discrimination? Well, first we can augment the framework I presented, the simple hiring framework, to allow for inaccurate beliefs. The way we propose doing so in our paper is using a model misspecification approach. So we assume that the manager holds subjective beliefs, where the hat denotes the subjective rather than the true distribution. And the relevant beliefs, again, are the signaling technology, the conditional distribution of the signal given productivity, and then the underlying productivity distribution. And these beliefs are inaccurate when the subjective distributions differ from the true distributions. And these inaccurate beliefs can lead to inaccurate inference about the candidate. As Milesh mentioned in the intro, when I put my theory hat on, a lot of my work is in the area of model misspecification. And one of the key things we've learned in this literature in the past decade or so is that, people in economics used to just informally say, well, if you have inaccurate beliefs, then eventually they'll go away in the long run. So this might be a short run phenomenon, but in the long run, everything will wash out. People will learn correctly. Well, we now know that's not true, that these inaccurate beliefs can persist even in the face of a lot of information about a candidate. They can persist asymptotically, and therefore they're definitely going to be situations where they are very much relevant for the decision at hand. They also may cause inefficient exit from the market. So even if they would eventually be corrected, if someone exits the market before they can efficiently learn about that candidate, then they're not going to be corrected for that candidate who exited. Why do we care about this source of discrimination? For the same reason we care about the other sources. if we want to know how to intervene effectively in order to mitigate discrimination, then we need an understanding of what's causing it. And the effective interventions when beliefs are inaccurate are going to differ from those for accurate statistical or case-based sources. All right, so one of the key components of the paper is to think about how we can identify the source in this expanded framework. As I said, the outcomes-based method is often used to distinguish between case-based and statistical sources in classic papers just looking at those two sources. However, the key assumption of that method is that beliefs are accurate because you're looking at the true distribution and then you're comparing it to the decision to see if it's consistent. But if beliefs are inaccurate, then it doesn't matter if it's consistent with the true distribution or not. We still can't say what's generating that discrimination. So we show that erroneously assuming accurate beliefs is going to lead to a misidentification of source. It's going to cause people to misattribute discrimination from inaccurate beliefs, specifically to preferences. But relaxing the assumption of accurate beliefs creates an identification problem, and that we can no longer use this outcome-based method to identify source, and we need to think about new ways to do so. The one thing we can potentially do as the outcome-based method is we can potentially rule out accurate statistical discrimination. So we can say sometimes whether a given decision-making is consistent with accurate statistical discrimination, and if it's not, then we can know that that's not the driver. So that's important in of itself because often accurate statistical discrimination is sort of a different category than something coming from preferences or inaccurate beliefs, in the sense that, preferences or inaccurate beliefs is really sort of treating people who should have the same posterior belief about productivity differently. All right, so how can we identify the source when beliefs may be inaccurate? The most obvious one is you can actually elicit subjective beliefs. This turns out to be plausible in some settings, not plausible in others. So in settings where this is not plausible, we also show that another alternative is to do what we call manipulate information. In other words, vary the number of signal draws that an evaluator observes. So for example, if you're looking at whether discrimination is occurring on, say, Airbnb against hosts, one thing you could do would say vary the number of reviews that someone sees and compare how discrimination changes across time in response to those different numbers of reviews. It turns out that this can identify preferences in the sense that the set of preferences and beliefs that are consistent with a given level of discrimination, if you say observe one review, are going to be different than the set of preferences and beliefs that are consistent with another level of discrimination, and if you observe, say, 2 reviews. The last thing, and I'm going to touch about this more as I get to the dynamics work, is in specific settings, you could also write a structural model that would say make different predictions about discrimination, and then try and, based on different sources, and try and use that to tease out the predictions. All right, so I think I'm going to skip this experiment just in the interest of time, since we're already about 20 minutes into the talk. But essentially, the last component of the inaccurate paper is we just do a simple online experiment in order to show what would happen if you, say, made the assumption of accurate beliefs and use the outcomes-based method. You'd misidentify the source, and then, again, showing that once we can elicit beliefs, you can then pin down the inaccurate beliefs. Okay, so this is just sort of in summary. It's a common method you can use to try and tease out sources is to do this belief elicitation. All right, so as we've seen so far, discrimination is usually studied in static settings. The work I've been talking about so far is just looking at a single decision in isolation. And as I said, in economics, we say discrimination occurs if, say, a male and a female who generated the same product arrive and they receive differential treatment. The male is more likely to, say, receive a positive evaluation or be higher than the female. So let's think about the dynamics of how the dynamics might evolve over time. And this is based on work I have with Alex Emos and Michael Rosenberg, published in 2019. And so let's suppose we're looking at, say, an online software platform. The different users are generating, say, code or some other sort of project, and you can see the history of their past evaluations. Let's suppose specifically you can see some sort of aggregate reputation score, which is, say, the number of positive or accepted assignments they've had in the past. Now, we saw here that these, say, new users, so no reputation yet, we're going to see discrimination if they present similar software products and the male workers favored over the female. Now, let's suppose that they both received 100 positive evaluations in the past. And again, they arrive with the same product. Now, one thing might be, well, there's whatever is generating this discrimination is still around. People sort of have some sort of animus against women, say. And so the male is still going to be favored, even though they have these really high reputation scores. So specifically, if there was taste-based discrimination, the prediction would be that it doesn't matter if there's 100 positive evaluations or none, the male worker is still going to be favored. Now, we could also say, well, if it's informational, if it's statistical discrimination, then really priors matter a lot when there's no other information about the candidate. You don't know anything about that individual's track record, so you really have to rely on population averages. But after you see 100 positive assignments, you have really precise information about that particular candidate. And so the population average doesn't really matter. Your precision from this information is, puts very low weight on the prior because you have a lot of individual information. And so if that's the case, we may then see discrimination disappear. We may see that the male and female worker receive close to equal treatment once they have sufficiently generated their individual track records and they have the same track record. Or we might think, well, if there was this initial discrimination and that woman was able to get this really high level of reputation, 100 positive task assignments, even though she's facing discrimination, she must be really good because she had to overcome all of this initial discrimination to build up her reputation. In fact, she actually must be better than a typical male with 100 reputation points because that male candidate wasn't overcoming discrimination. So we might even see the woman being favored later on. All right, so why would we want to study these dynamics of discrimination? As I said, it's difficult to identify the source in static settings. This dynamic reversal I just suggested, we show theoretically is indicative of inaccurate belief-based discrimination, as I'll talk about a little bit more in a couple of slides. So it can really help pin down the source. We saw how taste-based, accurate, statistical, and inaccurate lead to different predictions. Also, it's really important for interpreting discrimination in a given decision environment. It's important to have a sense of what the larger pipeline looks like. And this is because discrimination at one stage can be a function of precursor to discrimination at a different stage. And so, for example, here, if we see the woman being favored, if we just looked at this decision with the high reputation workers, we might say, oh, discrimination is not a problem. The woman's actually favored. We don't need to worry about it. But actually, the whole reason the woman is favored is because she faced earlier discrimination. And so in that sense, in order to understand the full picture, we would miss that important component if we just looked at the static decision. And so again, the policy implications for the type and the timing of the intervention may depend on the dynamic pattern rather than just the pattern at a given stage. And also, if we want to assess welfare, again, we need to understand how it evolves across time. All right, so in order to look a little more closely at this dynamics, we ran a field experiment. Our setting was a large online mathematics forum. It's where users can post questions or answers from accounts with male or female usernames. That's what we did for the field experiment as well. And other users on the forum can vote on posts. Now, the key component here is that there's a publicly observable reputation that aggregates the past votes of workers. And using our definition of direct discrimination from economics, we say that there's gender discrimination if similar content posted to male or female accounts or accounts with male or female perceived usernames receive differential treatments. Importantly, holding reputation fixed. And this is that key component. We're thinking of reputation here as the signal in our action rule, A of GS. G is the group identity perceived from the username. S is the signal, or reputation is the signal. And direct discrimination is going to occur if the same reputation is treated, evaluations for workers with the same reputation are different based on their group identity or their perceived group identity. So just to give you a sense of what this looks like, here we see a question posted right down here. Very prominently, you can see the username. 184 is the reputation here. So the important thing is that this username and reputation are prominently featured right next to the post. And then over here, you can see this is how the new reputation is generated. If I were on the site, I could click this up arrow to vote it up. That would be 5 or 10 reputation points, depending on question or answer. I could also vote it down, and that would be a loss of some reputation points. All right, so let's think about reputation and how it interacts with the dynamics of discrimination. Now, reputation is a signal of past performance, as I said, and therefore ability or productivity on the site. And importantly, it's endogenously generated by the evaluations of previous posts. So it's a subjective form of information. It's filtered through other evaluators' preferences and beliefs in evaluating the prior posts. And therefore, interpreting the reputation is going to depend on the beliefs about other evaluators. If I think other people are discriminatory, I'm going to know that there's the woman who received 100 reputation points has generated higher quality content than the man. Whereas if there's no prior discrimination, it would be similar quality content. All right, so we want to say, well, if a female faces a higher initial threshold to receive an upvote, how is that going to affect discrimination on future posts? So our method, or what we did here, is we generated 280 upper level undergraduate to graduate math questions, analysis, probability, those sort of topics. We posted 140 questions on accounts with male or female usernames, taken from the top 100 US names list, and no reputation, so they were new accounts. This was randomly assigned so that on average, the quality of the questions was similar across the two sets of accounts. And then we also built the reputation on 140 accounts until it was at least 100, which at the time of the experiment was the top 25th percentile on the site. Now, here's the really important step that let us have a really nice ability to identify discrimination at the two reputation levels. Now, of course, if there's discrimination going on initially, we're building these reputation points under usernames. If there's discrimination going on initially, the past post that led to 100 reputation points for the male accounts is going to be different than the past post that led to 100 reputation points for the female account. And so we wouldn't have exogenous assignment of reputation conditional on quality of questions, which we really need to identify causality, discrimination, direct discrimination, or causality at the high reputation accounts. But the site lets you randomly reassign usernames, and it changes. There's no publicly observable history of a prior username. So basically, you change the username. All the past posts now have this username. There's no way you could figure out that username changed. So what we did is we randomly reassigned the usernames. We did 35 male to female, 35 female to male. And so essentially what that did is that then randomly assigned reputation to accounts with male and female usernames. And so this is going to give us an exogenous variation in reputation that we can use to causally identify the impact of gender on the evaluation at those high reputation accounts. We again posted 140 questions on the accounts with high reputation and looked at discrimination there as well. All right, so what are our predictions? We have a theory model in the paper. I don't have time to present it today, so just take my word for it, but the theory model, it's a simple model of learning and how people update from prior evaluations in a social learning context, since this is social information or information generated by other people. The initial discrimination, at no reputation, we predicted that women would face discrimination and that male accounts would receive more upvotes than female accounts for posted questions. Of course, just seeing this in isolation, we can't say anything about the source. It could be generated by preferences, accurate beliefs, inaccurate beliefs. This one piece of information wouldn't tell us anything about that. But then we also looked at the interaction of gender and reputation. And from the theory, we see that if it's preference-based, there's going to be no effect of reputation on discrimination. We'll also see discrimination against females at the high reputation accounts. Whereas if it's belief-based, then the reputation should mitigate discrimination for the argument I previously gave. As you have a lot of individual information, you rely less on the population averages. And then lastly, if it's belief-based with bias or inaccurate beliefs, we actually show as a possibility result that for sort of a plausible model of updating, reputation can reverse the direction of discrimination sometimes. So here we have an impossibility result. If all evaluators have the same accurate beliefs, then we'll see reputation decrease if it's due to accurate statistical discrimination, but it would never reverse. So reversals are not possible with accurate beliefs. Whereas our possibility result, so it shows one plausible way in which when there are a subset of evaluators with inaccurate beliefs and another subset of evaluators who are aware of that bias, then we could potentially see this discrimination reversal. All right, so what do we find? Well, first we look at the discrimination against females with no reputation, and indeed we find significant discrimination against the accounts with female usernames. Specifically, on average, so on the y-axis here, we have the change in reputation. Remember, 5 reputation points is an upvote on a question. And so here we see that males receive about roughly 50% more reputation points than females on those initial posts. So it's significant and the magnitude is relatively large. Whereas in contrast, what happens at higher reputations? Well, indeed, we actually do see a reversal. Here we see that the change in reputation is much higher for female accounts than male accounts. Similar to the initial, it's about 50% higher for these female accounts than male accounts. And so indeed, we are seeing this reversal of discrimination. Looking at it in a regression form, we can put everything in. We see a significant interaction between male and reputation in the sense of, in the same direction we would expect. And so what does this tell us? Well, first of all, it suggests that this discrimination is stemming from inaccurate beliefs. So as I said in my, when I was talking about the inaccurate paper, if you can't elicit beliefs, which would not be possible in this environment, and you can't manipulate information, well, you can, you can also write down a structural model and make predictions about how the different sources would manifest, which is what we did here, and then test those predictions and see if you can use that to identify the source. So how to interpret this result? Well, first of all, it gives us a word of caution when evaluating whether discrimination exists. There's this very interesting post on Marginal Revolution a couple of years ago saying that the Australian behavioral economics team conducted a randomized trial of hiring in which applications for senior positions in the Australian public service were reviewed and ranked. And by comparing outcomes and treatments in which gender, minority status, and Indigenous status could be inferred with outcomes that were anonymized, so de-identified the applications, the researchers were able to test for bias, and they actually found that participants were more likely to shortlist female candidates when they were identifiable compared to when they were de-identified. And so they concluded that, look, discrimination is actually not a problem. Not only do we not need to anonymize applications, but actually the applicants that we thought would be discriminated against were actually favored. So, great, we don't need to worry about discrimination. But the word of caution, what do we see here? Well, it's applications for senior positions. And so maybe it's not that discrimination is not an issue. Maybe this favoring the female candidates is actually due to discrimination that occurred at the entry level positions before they were even able to reach the senior position. So really that shows that if we look at a static result without considering the dynamics, we might completely misinterpret what the underlying pattern of discrimination is in the broader context of the hiring market. Okay, so I'm going to just wait for a minute. If anyone has any questions, I'm happy to take a question or two here before moving on to the third piece.
Hi. Yeah, so everyone, if you have a question, feel free to post it in the chat and I'll relay it to the speaker. I guess this is very interesting. Thank you. I'm curious about is it okay then to have inaccurate beliefs because we get this reversal thing, or would the world have been better off if, I'm curious about interventions really, so if I could sort of make interventions and change the inaccurate beliefs, maybe push them to being more accurate, would that actually be better, or is this kind of good to have these reversals?
So great question. So two pieces that I answer. This actually segues really nicely into the next topic. One is that, our model is just able to identify whether our beliefs are accurate or inaccurate. So our theoretical model shows that a reversal is inconsistent with all evaluators having accurate beliefs. But we don't know anything about how those beliefs are accurate or inaccurate. So we call it a possibility result. In our possibility result that illustrates how a reversal may arise, we say, suppose that there's two types of initial evaluators. One believes that on average, females have lower average productivity than males. The other believes that they're the same. That's going to give you average discrimination against females in the first evaluation because you're averaging people who think there's people who think both groups are the same and people who think one group is worse than the other. Now, if we think about what happens to each of those types of evaluators dynamically, well, the evaluators who believe that there's initially a difference, the same thing applies in the sense, the same result applies with the accurate statistical, in that as they get more information about the individual, their differences in priors matter less. So their discrimination decreases across time as they see more information about the individual. And then the other component that's important here is the how the evaluators believe prior evaluations were generated. And so we assume that the evaluators who have the same beliefs about group M and group F are also aware of the bias of other evaluators. And so actually their discrimination reverses because they say, look, initially we don't discriminate, we have equal treatment for the first evaluation, but now we know that these female workers have been facing discrimination. And so actually we should, they're essentially they had to generate higher performance in order to get the same evaluation. And so then on average, as the discrimination of one type decreases and the discrimination of the other reverses, it can average to a reversal. So that's just one, that's what we call that one a possibility result, versus the impossibility result is the impossibility of a reversal with accurate statistical discrimination. And so there could be many different ways that beliefs could be inaccurate. With the data we have here, we can only identify that they are inaccurate, but not how. So a really important question going forward is, what are the many different ways in which beliefs can be inaccurate? The obvious one is that people have wrongly believe that there's differences in the productivity distribution or incorrectly interpret signals. But as I said, when you have social information, so the social information is an important component here. We would not see such a reversal with that exact model if it was exogenous information. And it's important that people with biased beliefs are generating the information that subsequent people see to give them.
That's great, because I guess another question I have is whether you can rule out that people are just making mistakes, like they actually have correct beliefs, but I don't know, they're trembling or they're whatever other sort of models of mistakes that economists have. So if you ran this side by side with the exogenous thing, you could rule that out, I guess.
Yeah, so I mean, mistakes, I think you would sort of see that as, you'd have to have a model of why the mistakes were different across group identity, because otherwise they should average out to be the same.
Okay, yeah, that's true.
And if they were different across group identity, then, I guess that's sort of then that's another way to have you're making more mistakes against evaluating females than males. That is something I would call discrimination. If you're putting less effort into it, say, or whatever could generate the mistake. So the other question is, exogenous. So in the interest of time, I didn't present this piece of the paper. There's a third piece to the paper. The results I just presented are for questions. Questions are subjective, and we also look at answers, and we predict that evaluating answers is much more objective. So you see a mathematical answer, generally it's right or wrong, whereas the criteria for evaluating a question is it interesting, is it creative, did it stimulate your thinking, blah, blah, blah. And so in the case of something objective, preferences and beliefs play a lot less of a role, because you can just, even if you think that, say, females on average are going to produce lower quality answers, on a particular answer, you get a very precise signal of the quality of that answer. And so your prior beliefs matter less. And actually, indeed, on the initial accounts, we found no discrimination answers, but discrimination in questions. It's suggestive that it's coming from beliefs, given that there's no differences in the answers. So, there's different things you can piece together. The other thing I want to say about the social information, that's an important component, because once you have social information, it's not just your belief about the productivity distribution and your belief about the signaling technology, it's also your belief about how other people have other people's preferences and beliefs. And so that starts to get a lot more complex to be accurate about. You need to, what if evaluators say had no believe that group males and females had the same distribution of productivity, but they also believe that all evaluators believe that. So they were unaware of the biased evaluators. Then they might just take a recommendation at face value, and actually they should be, putting more weight on the quality of a female with that recommendation than a male, given that there's bias. So that's an important thing to keep in mind, is the source of the information. Is it social or endogenous versus is it exogenous? Now, another thing, and this segues really nicely into the next, what I want to talk about in the last 10 minutes or so, is, it's important in order to interpret the, as I'm arguing, it's important to look at the discrimination in a given stage and as a part of a broader picture of the dynamics. Here we would see a reversal, and if we didn't think about the dynamics, we might say that discrimination is not a problem, whereas actually this is actually indicative of discrimination earlier in the pipeline. So we might say, all right, well, now discrimination earlier in the pipeline is a problem, but hey, we got to this reversal, and so we should be worrying about discrimination earlier. But once we're here, we don't need to worry about that. Females are actually favored. That's great. They're actually being favored eventually. So good for them. That would actually also be a wrong conclusion. And why is that? Well, yes, indeed, the females with the same reputation history are being favored over the males. But as I said, direct discrimination is a very specific notion of discrimination. And so maybe that's not what we really want to be looking at here. Do we want to be looking at males and females, high reputation males and females with the same evaluation? Or should we be comparing males and females who generated the same pattern of posts? And if we compared males and females generating the same pattern of posts, actually we would in general still see the discrimination against the females. And so just focusing on direct discrimination here is actually missing an important component of total discrimination, what we're going to call total discrimination. So that segues to the next thing I wanted to talk about is—
before you get there, I think there's one more question from the chat. Kevin Stangle asks, do you have any sense of discrimination in this context with decision maker utilities to various types of errors? For example, if I have a very high false positive cost, maybe I'm very pessimistic on the disadvantaged group. And even if I'm aware that I might not have much good information about applicants from that group, I might be unwilling to explore. It's like micro-founding, I guess, the cause of the misspecified belief.
Yeah, so I think that's very context dependent. And I think it's also a very important question, is thinking about, there's many different mechanisms that can generate inaccurate beliefs, and there's many different ways beliefs can be inaccurate. It could be on the underlying distributions, as I said, it could be on higher order beliefs about how other people generate information. And so I think some work is, a lot of sort of, some work in economics is just starting to think about this, but I think that's really an important open question going forward, is once we open the door to inaccurate beliefs and show that they may be an issue, thinking how are beliefs inaccurate? How does it depend on, whether information is social versus exogenous? Is it more of an issue in one of those contexts versus the other? And if beliefs are inaccurate, how can we correct them, and questions like that. So no, from this data, we can't really say very much about the way beliefs are inaccurate. That specific example that people might have a really high cost of, hiring someone who's low productivity, but essentially there's whatever the decision model is, you can have a model with high cost of making a mistake and hiring someone, but it's really, that's not going to generate discrimination unless there's group differences in, say, the signaling technology, or there's something to generate discrimination. Just that high cost, if there was no discrimination, then it should be, applied equally in terms of making conservative decisions for across the different group members. Okay, so as I said, I think once we see this reversal, it also suggests that, a sort of naive conclusion would be, well, discrimination is a problem earlier in the pipeline, but hey, once we get to the senior level, we don't need to worry about it because we see this reversal. So actually, if you can make it up to the top, then it's, great to actually be from an underrepresented group. But I'm going to argue that this dynamic result suggests that we should actually have a broader definition of discrimination. And specifically, if initial discrimination occurs, as we saw in the experiment, does comparing subsequent evaluations holding fixed reputation give us an accurate picture of discrimination? And so because reputation is endogenous and may reflect different information for different groups, we may want to instead say hold fixed the underlying productivity or quality of posts generated by the workers, rather than the way they're evaluated that's filtered through the preferences and beliefs about their group. The sort of simplest way to think about it is the first post was one signal that was evaluated. The signal in the second post is the reputation. Now, what if the signal in the second post was just the information that came from reading the two posts? In that case, we may not see a reversal, even though we would see a reversal for the reputation. And so I'm going to give an example that should hopefully make that a little clearer. If I have time, I only have 5 minutes left. But the other thing I wanted to point out is there's a vast literature outside of economics that emphasizes broader views of discrimination in sociology and law. Disparities are often studied in a systems-based approach, where discrimination can arise indirectly as well as directly. It can come indirectly through cumulative actions. As Juva talked about a lot in the first half of this tutorial, computer scientists study how algorithmic disparities can arise from biased data collection and training systems. So I'm going to skip this redlining example since Juva ever so nicely talked about redlining in his tutorial. And in recent work I have with Peter Hall and Alex Emas, we have a paper that we should hopefully have a working paper of within the next week called Systemic Discrimination Theory and Measurement. And we're developing a model to measure these broader notions of discrimination. We propose a general theoretical framework to distinguish between direct discrimination, this causal notion of discrimination often used in economics, from systemic or indirect discrimination. And what we do so is we expand the basic hiring task I presented, we embed it in a larger economy of other managers and firms, potentially in other sectors or different time periods. We let GI, SI, and YI denote the random variables corresponding to group identity, signal, and productivity for worker I. The important new component here is that we need to define the systemic discrimination with respect to something. And we call that something the qualification, YIO. This is something the worker enters the economy with. It's a choice variable of the researcher. And it allows us to say what discrimination has occurred through the whole system since workers had this given level of qualification, say. We could set it to be 0 or a constant, which essentially measures disparities, all disparities. We could set it to be current productivity, which is going to measure just discrimination coming from signaling, or it could be something in between. And importantly, productivity can be generated endogenously from the qualifications, as well as the actions of other managers and firms in the economy. In other words, what we call systemic forces. Given this expanded framework, our definition of systemic discrimination is that the action rule, where we fix G, we fix the group identity in the action rule, and we just take its distribution with respect to the signal, is not independent of group identity, conditional on the qualification. In other words, this is saying discrimination can come indirectly from how the distribution of non-group characteristics among equally qualified workers depends on their group identity. And that gives us this broader notion of total discrimination, where the action rule is not independent of GI, conditional on YIO, taking into account both how it depends on GI, which is the direct sources, the first argument, as well as how it depends on how SI relates, the signal relates to GI, and that second component is the indirect or systemic component. All right, so similar to direct discrimination, we can say, well, what are potential sources of systemic discrimination? There's two key components. The first is that there could be differences in the signaling technology, that is the distribution of the signal relative to the qualification and a given level of productivity. And then there also can be differences in the productivity distribution relative to the qualification, which we call a technological source. So the first is an informational source, the second a technological. It can stem from direct discrimination in prior decisions or other domains. In other words, if we have social information, as I mentioned, higher order beliefs can be a source of discrimination, how to interpret that subjective information. And it can also be determined from other decisions determining whether a signal is generated. For example, does somebody have an opportunity to take a test and generate a signal, or build a skill? In other words, if someone has an opportunity to be hired for an internship and build their productivity for the next position they apply for. Importantly, it can also stem from design choices for the current signaling technology. So something like redlining, you could argue, is a design choice. People didn't have to use zip code to predict creditworthiness, but it can be a way when direct discrimination is banned to try and indirectly maintain discrimination through a choice of which signaling technology to use. All right, so what we do is we propose a way to measure systemic discrimination by decomposing total discrimination into a direct and a systemic component. Direct discrimination can be identified by standard economic tools such as auditor correspondence studies. Total discrimination can be identified by the qualification distribution, as in recent work by Arnold, Dovey, and Yang, looking at discrimination in a criminal justice setting. And we show that systemic discrimination can essentially be found by the residual in this decomposition. So total discrimination in a given qualification, this is measuring disparate treatment relative to some initial qualification chosen by the researcher, is equal to the probability of each signal given that qualification and the group identity times the direct discrimination at that signal plus the systemic component at that qualification. And here, this is just a figment of the decomposition. You need to use the signal distribution for one group identity and the systemic measurement. Remember, systemic is coming from fixing a group identity in the action rule. So you fix it for one group identity, you fix, say, the action rule for group M with respect to the signal. And then you also, so essentially that nets out any direct, and then you just look at the signal distribution for the other group. So this is just a classic blinder decomposition for each qualification. So I don't have time to cover too much of this since I'm just about out of time, but essentially what we do is we develop some theoretical examples about how systemic discrimination can manifest. I'll quickly go through this. And then we also empirically identify it through this decomposition in 2 online hiring experiments. And one, the systemic, is coming from what we call inflationary signals, biased earlier evaluations, similar to our dynamics paper. And the other, it's coming from this idea about whether a signal is generated whether a subsequent evaluator observes a signal depends on whether the first evaluator hires the worker or not. So you can either have an uninformative signal or an informative signal, and whether it's one of those two depends on the decisions of prior evaluators. All right, so in closing, let me quickly go through this example to illustrate what we mean by systemic. So suppose a recruiter evaluates a worker by observing their group identity and their signal. We denote the signal of the recruiter by SR. This is an exogenous signal, which can be, say, some sort of test or something else that's just coming exogenously into the model. We normalize the signal so that it corresponds to the expected productivity conditional on the signal realization. And we assume this productivity and the signal is orthogonal to group identity. So there's no scope for accurate statistical discrimination here. Here, we're going to set the qualification equal to the signal the recruiter observes. And so we want to measure discrimination in subsequent rounds for workers who enter this model with the same exogenous signal. In other words, they generated, say, the same quality post on their first post on the math forum. The recruiter then submits a forecast with direct discrimination or bias. We're not modeling where this is coming from. We're just specifying an action rule that exhibits direct discrimination. Specifically, they inflate the signals of group M workers. If they see a signal S, they give an evaluation of S plus 1 to group M workers and evaluation of S to F workers. Then the hiring manager observes this evaluation as well as group identity and makes a wage offer to the worker. All right, so the hiring manager's information is social or endogenous because it's the forecast submitted by the recruiter. All right, so let's first suppose that managers take signals at face value. So in other words, they're not aware of the bias of the recruiter. If they were, they would want to undo it. They're not inherently discriminatory themselves, but they're just not aware. They think that everybody is like them and doesn't make discriminatory decisions. In that case, their wage is just going to be their willingness to pay, which is the forecast of productivity. And so their action rule is independent of group, and it's just equal to the signal, the reported forecast of the recruiter S. So there's no direct discrimination here. As you can see, this action rule doesn't depend on group. But there's positive systemic discrimination in that for each potential group identity that we can fix in the action rule, the expected wage offer given a given signal or given forecast observed by the hiring manager, if the worker is a male worker, the expected wage offer is S plus 1, whereas if the worker is a female worker, the expected wage offer is S. So we can see that even though there's no direct discrimination, there is systemic discrimination occurring here from this, essentially, and this is coming from the inflated forecast of the recruiters. You really should be undoing their bias, but the managers are not aware of the discrimination. And so this is going to lead to positive total discrimination. Again, taking the expectation of the action rule with respect to both random variables, we see that the difference between the willingness to pay for the group M and group F workers is going to be equal to 1. All right, so in contrast, if managers were aware of the bias, they would actually directly discriminate in the opposite direction. They would undo the inflation of the male workers' signals and offer them a wage of S minus 1 when they observed a forecast of S, whereas they would just, again, offer a wage of S when they observed a forecast of S for group F. And so this would have the same systemic discrimination as before, but now it's going to be offset by the negative manager direct discrimination, which leads to no total discrimination. So in other words, in order to undo earlier systemic discrimination, we needed direct discrimination in the opposite direction here. And so this gives us a lens for interpreting direct discrimination reversals as documented in the dynamics paper I presented. In other words, if we say have a subset of evaluators who are aware of the bias and another subset who are not, then on average, we can see direct discrimination in the first round, a reversal of direct discrimination in the second round, but we can still see total discrimination against group F. And so the motivation for one of the motivations for this expanded framework is that just seeing the reversal of direct discrimination could actually be misleading in the sense that there still is total discrimination against group F. Workers from group F who arrive at the same productivity signal as workers from group M are systematically treated differently in later rounds, even though when you condition on the endogenous information, it looks like they're being favored. All right, so in conclusion, so I'm over time here, direct discrimination in one period or domain can drive systemic discrimination in another. Standard economic models and measures miss these channels. It's becoming more important to be looked at recently empirically. So the US EEOC launched nearly 600 investigations into systemic discrimination in 2020, flagging what appear as facially neutral hiring practices. And so all it says is that there's a lot of exciting new research and open questions at the intersection of economics and computer science in terms of how we can fairly screen individuals. and rectify the long-term impact of past discrimination stemming from systemic forces. And so there's a lot of important design and policy questions, both theoretically and empirically, related to sort of thinking about these broader notions of discrimination within economics, and also, nicely connected to a lot of the algorithmic work in computer science. So I'll stop here. I'm sorry that I went 5 minutes over.